All right, let's get this going. We are going to talk about arcs and chords. And today you're going to recognize and use the relationship between arcs, chords, and diameters. So let's start off with a little theorem. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Okay, so what that is trying to say is if, and remember, if and only if kind of goes both ways. If this chord is congruent to this chord, so those two are congruent, then the arcs that are formed by that are also congruent. Now, the other way around, if the arcs are congruent, so are the chords. That's what if and only if kind of gives us. Okay, so now in the next part, and here's an example. We want to talk about an embroidery hoop, I guess. And we can say here chord AB is congruent to chord CD. So find the measurement of the arc CD if the measurement of arc AB is 60 degrees. Notice that does say degrees. So then measurement of CD, since that theorem says that they have to be equal, is also 60. So there's an easy example, right? Let's see a slightly more difficult one. Alright, so here's a different example. We're going to say here circle J and circle K are congruent, and that arcs MN and arcs PQ are also congruent. So thus, we want to be able to find PQ. What does that mean? It means we can say these two lengths are congruent. So I can say 2x plus 1 is equal to 3x minus 7, and we can do variables to the left, numbers to the right, and we would get something like negative 1x is equal to negative 8, and then we can divide by negative 1 to get x equals 8. Now keep in mind that just finds you x, and this wants to find us PQ, so we'd have to put the 8 back in, say 3 times 8 minus 7 to get that would be blah 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 24 minus 7, which would be 17. So the length of PQ, or PQ, would be equivalent to 17 units, whatever that might be. Simple enough example, right? Yay! Alright, let's look at some more theorems. If a diameter or radius of a circle is perpendicular to a chord, then it bisects the chord and its arc. Okay, so what does that mean? If a diameter is perpendicular to chord XY, then it is cutting XY into two equal halves. XZ, ZY would be congruent. Then that's like a wow. Plus, also keep in mind the arcs would also be congruent. So XB and BY would also be congruent. Theorem 10-4 or 10.4. Perpendicular bisector of a chord is a diameter or radius of the circle. Okay, so if something is a perpendicular bisector of a chord, then it has to be a diameter. So that's basically what that says. Example. Okay, so in circle S, the measurement of arc PR is equal to 98. So find the measurement of arc PQ. Okay, so if you were to say on this one, like, alright, based on that theorem, we have a perpendicular bisector, then we are saying, or since it's perpendicular, it is going to bisect. So that means then these are equal, and then if this is 98, then that whole thing right here is 98, then this would just be half because I'm cutting into equal halves. So the measurement of PQ would be 98 divided by 2, which would be 49. So this one would be 49 degrees. Okay, and also let's do this example. What about if I wanted to find PR? Okay, if TR is equal to 6, then PT would be equal to 6, or let's say TP would be equal to 6, and both of those being equal to 6, then the whole thing across PR would be equal to 12 units. And easy peasy, simple as can be, right? Right. Alright, so next theorem. In the same circle, Or congruent circles, two chords are congruent if and only if they're equal distance from the center. So now we're also saying that these things are equal distance from the center. So not only if two chords are congruent, that means they are also equal distance from a center. Wow! What? Yeah. So there you go. So let's look at that part, shall we? Wow, excuse me there. Okay, so in this one we're saying in circle A, WX and XY are equal to 22. Find AB. Okay, so here we're saying these are 22. And then, so we could also say that would be, we know that they're going to be congruent. So that means since those are the same, then based on that theorem, then we can say they are the same distance from the center, which means then these two things are equal to each other. So I can say 5x is equal to 3x plus 4. Variables to the left, numbers to the right. 3x, and that would give me 2x equals 4. So x equals 2. And again, that's not the answer. We need to go plug that back in and say, all right, if I put 2 in place of, let's say, okay, for AB, whoops, I don't want to keep that 2. But if I put it in here in place of the AB, I could say 5 times 2. So AB is equal to 10. So that, because I put the 2 in there and said, got that. So now I know AB is 10, and that just answers that question. So there we go for that. Now, let's try the other one. Okay, so now notice in this one, we're going to say in circle H, this is this bottom one right here, obviously. PQ is equal to 3x minus 4 and RS equals 14. Find x. Now, because these are equal distance from the center, that is telling me based on that theorem that I can say that these have to be congruent. The chords have to be congruent. So this and this are equal. So I can say 3x minus 4 equals 14. And I can solve and say 3x is equal to, add 4 to there, 18, divide by 3. And I get x is equal to 6. And that's all they asked me to find, was that x is equal to, what is x equal to? So this time I am done. And that's really it, guys. It's just a matter of, thinking it out thoroughly and just trying to answer it correctly. Thank you so much for your time. Y'all take care. Have a great day.